Hello, and in this presentation I'm going to cover current Martian exploration with robotic vehicles. And as mentioned earlier in the course, Viking and Mariner were the first to analyze Mars. And these have since been followed up with orbiters and rovers, namely Spirit in 2003 and Opportunity, its twin, in the same year. And in addition to that, Curiosity in 2011. These have provided us with groundbreaking information, as two of the three are still functioning. The parts of a rover are mentioned on this diagram. Notice the panoramic camera, solar panels, and radio antennas necessary to communicate with the satellites in orbit, which relay the information to Earth. In addition, rovers have 6 wheels, because this is a stable drive system. Now, instruments on the rover include a thermal spectrometer, panoramic camera, a Mossberg spectrometer, and an X-ray spectrometer for imaging and determining mineral content, respectively. The rovers are located in these positions on Mars. Opportunity, as you can tell from this diagram, is located in what is thought to be a dried up riverbed. Spirit was put in a more desolate location, and Viking and Phoenix are shown as well with Curiosity. Now, Spirit has since lost communication. Its last known communication was in March of 2010. Opportunity and Curiosity are still active, and active research is continuing, as NASA's JPL website shows. Opportunity and Curiosity are providing information live. Now, the goals of this mission were to determine if the conditions for life were present at any time, and to analyze rock and mineral content to determine if water is on Mars. In addition, atmospheric conditions are being studied, along with ambient radiation, e.g. ultraviolet radiation. Spirit, volcanic rock, and terrestrial observations have shown that Mars does not currently have the conditions for life. And Spirit has been dead since 2010, and it was the first of the twin rovers in 2003. Spirit also was able to determine the composition of volcanic rock using its instruments. Opportunity is still active. It determines that water was once on Mars, and it landed in a former riverbed whose geologic formations water had to have created, and it analyzed the content and determined the sulfate content of the minerals. One example photograph from Opportunity is this one here. Notice the interesting geologic formations and the real color image from Mars. Such high quality images have been provided on demand by these rovers over the last 10 years. Curiosity is the most recent rover to have traveled to Mars. It found the past environment was well suited for life. It was launched in 2011 and is the first rover to determine the age of the Martian crust, estimated to be 4.2 billion years. Instruments on Curiosity include 10 times the amount of scientific instruments as earlier rovers, and include chromatographs and spectrometers. In addition, instruments are outfitted for the analysis of the Martian atmosphere, which has been lost over billions of years. Now, data sent from Mars, as mentioned earlier, is sent to the orbiters in orbit and then relayed to Earth. This has been the standard practice since 2001, and 48 gigabytes have been sent back in this way. For the orbiters to not exist and the rovers to do it themselves would be prohibitively difficult. The active orbiters, as mentioned before, 2 of the 3 rovers are still active, but we have 3 active orbiters: the Reconnaissance Orbiter, MAVEN, and Mars Odyssey, with their respective startup dates here. And this is a photograph of the Martian Reconnaissance Orbiter, which is the device which orbits Mars to relay the information from the rovers to Earth. Without this device, it would not be possible for the rovers to be of any real scientific use. In addition, this was used in studies of the Martian crust and atmosphere. The Reconnaissance Orbiter was launched in 2006 and spent 10 years in orbit. It's relayed 200 terabytes and has had over 900 million miles of transit. MAVEN is the Martian Atmosphere and Volatile Evolution Orbiter. It has studied the Martian atmosphere for relative terrestrial climate change observations, and it is analyzing the troubled Martian atmosphere, which is still an enigma to scientists today. Water was recently found on Mars in 2015, and the Martian Reconnaissance Orbiter provided the information necessary for this conclusion. And briny cold water does in fact flow on Mars, and part of the evidence was analysis of perchlorate chemical compounds. And the example photograph taken from the orbiter includes this one right here, which shows these streaks, these surface lineae, so to speak, which provide direct evidence that briny water does in fact flow on Mars. The temperature in these areas are basically estimated to be just warm enough. Future plans include further exploration as NASA plans to land on an asteroid in the 2020s and land on Mars in the 2030s. And it's essential for future missions to prepare for the relevant conditions. The end. Thank you for listening.